Hey guys, so we're going to take a look at some rotations. Now, I know you guys have done some of it already on Khan Academy, but I figured we would kind of talk about it a little bit more because when you do it on Khan Academy, it kind of just talks about things more in a general sense. And typically, when we go over rotations, we look at a few specific cases, and there are some nice rules that kind of help us do it in a faster way. So just to kind of reiterate before we get started with that, I wanted to kind of go over some of the vocabulary with you guys. So when we're taking a look at the vocabulary, the first thing we have is what it even is a rotation. Now, a rotation is when a shape is turned around a certain point. You could think about that like if you're standing in your room and you kind of move yourself around a chair. You are now rotating around that chair. The center of rotation is the fixed point in which the figure is turned about. And in that case, from what we were talking about before, the center of rotation would be the chair. So you are rotating around the chair, which was the center. And then lastly, you have the angle of rotation. And the angle of rotation is formed from the rays drawn from the center of rotation to a point in its image. What I like to think about with that angle of rotation is it's how much you're rotating. Like if you're rotating completely around the chair, that would be an angle of rotation of 360 degrees. Like you had seen with Khan Academy, you could have an angle of rotation of 30 degrees, 120 degrees, negative 30 degrees, negative 120 degrees. So it really just kind of depends on what you're doing. In Khan Academy, some of the things that you guys had looked at too was rotating around a point on the object, but we're really going to focus with this stuff about rotations that are strictly around the origin. Okay, so we're going to look at those rotations that are around the origin. So what we're going to do with that is we have some coordinate rules that will be used to find the coordinates of a point after rotating 90, 180, or 270 degrees about the origin. Okay. So with that, we have a couple of coordinate rules. So our first rule, the first thing we have to think about actually, is that all of these are going to be clockwise around the origin. So if we're looking at our coordinate plane, and I'm just going to draw a set of X and Y axes over here. If we're rotating clockwise about the origin, what that means is we're going to start right here and rotate this way. So we are rotating clockwise around the origin. Okay. So when we do a rotation, so for all of these, let's take a look at the coordinate of, actually, let me move that to up here. If we're looking at a coordinate, let's say we have the coordinate of 1, -5. Okay. So if we're taking this coordinate of 1, -5, and we're rotating it 90 degrees around the origin, we're going to take that coordinate and we're going to change y to where x is. X is going to go to where y is, and then we're just going to change the sign on that guy. So in terms of our 1, -5, we're now going to have -5, -1. So if we were to do a 90-degree rotation of 1, -5, it's going to become -5, -1. For a degree rotation of 180, our x and y coordinates are going to stay where they are. We're just going to change the signs. So we're going to have -1, +5. And for our rotation of 270 degrees, just like with number 1, x and y are going to flip-flop for where they are. But instead of changing the sign for x, we're going to change the sign for y. So we're going to now have a +5, +1 for that 270-degree rotation. Okay? And that's what we're going to do every time. These are those rules that we have. So depending on what our rotation is, that's clockwise, we're going to do these same ones. Now, I also want to mention, though, if something ever says that these are a counterclockwise rotation, this one here would, so the 270-degree one would then be a 90-degree if it's counterclockwise. The 180 would stay, and 90 would be a 270-degree. That's only if these are counterclockwise, though. Okay. So if you ever see a counterclockwise, you're just kind of going with 270 instead of 90, and vice versa. Okay. So our first example here says we want to rotate a figure using those coordinate rules. So let's take a look at that. Okay, so what we're doing is we are graphing our quadrilateral RSTU with vertices. R is 1, -1. So 1, -1. Let's go to there. So we've got 1, -1. So this right here is our coordinate for R. S is at 3, -1. T is at 3, -5. And then U is at 0, -4. That was very far away, but that's okay. So now I'm just going to connect them because we have a quadrilateral here. And now what we're going to do is we are going to find the coordinates of our rotation, and then we're going to graph that as well. So we're rotating our quadrilateral 90 degrees clockwise, which means that we are taking all of those coordinates and we're going to change them from x, y to y, -x. And I forgot my comma here. So that means for r prime, this 1, -1 is going to become a -1, -1, because we've flipped the 2. And then this guy here has to become negative. S prime is going to become -1, -3. T is going to become -5, -3. And then U is going to become -4, 0. Now, 0 is neither positive nor negative, so we don't even have to touch the sign on it. But now we have to plot these. So R is now at -1, -1. So R is now right here. So R prime. S is going to be at -1, -3. T is at -5, -3. And then U is at -4, 0. And then we're just going to connect our lines. And there we have our image after the rotation. And you can actually kind of see, like if you're looking at this on the screen and you just kind of turn your head 90 degrees, you can kind of see that it's actually making that rotation. Now, if we were in school, I would have you kind of like physically turn your paper and you can see that it's kind of doing that. But unfortunately, we're not. So this is the best that we get to do. So that's our first problem. So now let's take a look at the next example. And we're going to do the same thing. We are rotating our triangle JKL 180 degrees about the origin. So remember, when we do a rotation of 180 degrees, we are taking our original coordinate, xy, and we are merely just flipping the signs. So if x is positive, it's going to become negative. If it's negative, it's going to become positive. And then the same thing with y. So first, let's go ahead and plot our original triangle. So J is at 4, 1. So here we've got J. K is at 5, 4. And then L is at 7, 0. And then I'm going to connect my lines together. And then we can go ahead and get started on our translations. Okay. So J prime, we have 4, 1 to start with. So we're just switching the signs. So we have -4, -1. K was 5, 4. We're going to change the signs. So -5, -4. And then L was 7, 0. And now it's going to become -7, 0, because again, 0 is neither positive nor negative, so we don't have to worry about a sign on that. So here we go. -4, -1. This here is going to be my new J. K was at -5, -4. So this here is going to be my new K. And then L was at -7, 0. And then I'm going to go ahead and connect all of those points. And there we have our rotation. Again, if you have the ability to, I know not everybody might be on a laptop like I am, so rotating your head 180 degrees might not work, nor rotating your computer screen. But if you look at it, it's actually just kind of flipping everything by 180 degrees. If you happen to have it printed out, you can kind of definitely see it that way, but you are by no means obligated to print this out. You can kind of use it that way. And that's our example 2. And then lastly, we have a counterclockwise one. This is why I definitely brought it up before with our counterclockwise. But remember, a 90-degree counterclockwise basically just means that we're doing a 270-degree clockwise rotation. Because instead of rotating, because we're doing a 90-degree counterclockwise rotation, so it would look like this. So instead of doing it that way, we can also think that we're going 270 degrees counterclockwise, which is going to put us in the exact same spot. So a 90-degree counterclockwise rotation and a 270-degree clockwise rotation are the exact same. So let's take a look at this. So let's first plot our original point. So we have our triangle JKL. Again, it's the same coordinates that we had for that last one. So we've got 4, 1, 7, 0, and 5, 4. J, K, and L. And then I'm going to connect my lines. And now what we're going to do is we're going to do our rotation. So remember, for a 90-degree counterclockwise rotation, it's the same as a 270 rotation. It means that X and Y, they are going to become -Y, X. And sorry that that looks so terrible right now. So let's take a look at this. So J, we're switching where they are, but Y is going to become negative. So we have -1, +4. K, we're going to have -4, +5. And then L, 0 has no sign, so it's just going to stay. And then 7. And now we're going to plot our rotation. So J is going to be at -1, +4. K is going to be at -4, +5. And L is going to be at 0, 7. And then we're going to go ahead and connect our lines. And we are done. So now I hope that this kind of helps you guys out with rotations around the origin of those 90, 180, and 270 rotations. If you guys have any questions, feel free to please ask me. And then we will go over these at our next Zoom meeting. So have a great day, guys.